Within the scope of Mechatronics System Design course, we will present a project proposal for shared autonomous vehicle. The team members are Muhammed Kecici, Tanlas Panahi, and Berkay Gazdavian. Professor Adi Yeşildirek is our project consultant. The content for the presentation is project definition, goals and motivation, scope and task distribution, limitations and assumptions, literature review, mechanical design, stakeholder and stakeholders' needs, technical and functional requirements, system architecture and block diagram, working schedule, and deliverables. Project definition. In this project, we aim to design and produce a 1/10th scale shared autonomous vehicle prototype. This vehicle will be able to travel to the passenger location with no human involvement, and the location will be provided by the user interface. The shared autonomous vehicle will perform operations such as lane traffic tracking, classifications of the project, and path planning. Goals for the project: lane tracking with perception system, simultaneous localization and map, path planning, requesting vehicle with mobile application, and instant location tracking. Motivations for the project: bring solution to the traffic congestion, especially in large cities with shared autonomous vehicle culture, minimizing the carbon emissions by reducing the number of the vehicles in traffic, preventing the human-related accidents in the traffic with the autonomous shared vehicle concept. Scope of the shared autonomous vehicle. This part consists of 8 subsystems. Power management subsystem, mobile application subsystem for design of the mobile application, driving subsystem for one brushless DC motor and one servo motor, and we will design and produce a motor driver card. Motion control subsystem, lateral control with pre-pursuit algorithm, communication subsystem, communication with our mobile application and vehicle, decision-making subsystem, simultaneous localization and mapping or SLAM, and path planning. Perception subsystem for object detection and classification, image segmentation, lane tracking algorithm, obstacle detection, and depth camera. Mechanical subsystem, 3D modeling of the vehicle, structural and stress analysis of the vehicle. Task distribution of the shared autonomous vehicle. In this part, each subsystem has a leader. Although all the members will participate in all the areas, but the specific leader for the specific subsystem will lead and guide other members and will plan the progression. For example, in mobile application and communication subsystem, which are led by me, I will be planning and mostly guiding the other members. Power management subsystem and driving subsystem are led by Berkay Gazdavian. Motion control subsystem, decision-making subsystem, and perception subsystem, and mechanical subsystem are led by Muhammed Kecici. Limitations and assumptions. It's hard and costly to design and produce a real-life size autonomous vehicle, so we will make a 1/10 scale prototype. There are no functions such as climb up or climb down because these functions change the driving dynamics. Vehicle moves in two-dimensional plane, which is XY plane. Functional charging stations were not designed and only assumed. They will be presented on the map as marked areas.
Hi, I am Berkay Gaznevi. I will present this part of the presentation. After reviewing the literature scan, we saw some concepts and past projects. Now we need to explain some key concepts. The most important of these is the autonomous vehicle levels. You can see the autonomous levels in the table. Another important concept is SLAM. The 3 most important features of autonomous robots are perception, decision and actuation. SLAM stands for simultaneous localization and mapping. It's the process of mapping an area whilst keep tracking of the location of the device within that area. This is what makes mobile mapping possible. Task of path planning for mobile robots is to determine sequence of maneuvers to be taken by robot in order to move from starting point to destination, avoiding collision with obstacles. Sample algorithms for path planning are Descartes' algorithm, A star, D star. Path planning algorithm may be based on graph or occupancy grid. We will use A star algorithm. Let's take a look at similar projects now. The first of these is the Google Waymo project. The project started in 2009. Google has produced many prototypes now. The most important of these is the Google Waymo 1. The project is currently in the testing phase. It's called via a mobile application and autonomously goes to the marked point, but it cannot charge autonomously. Our project also includes autonomous charging. Another similar project is MIT Race Car. This project is part of educational robotic course at MIT. The mobile robot completes the track at MIT as soon as possible by recognizing its environment with a stereo camera. The last one is the F110 project. F110 is a community of researchers interested in autonomous mobile racing cars. The community has 4 missions: build, learn, race and research. Now I want to talk you about mechanical design. Our prototype was designed as a 1/10 scale mobile autonomous vehicle. This 4-wheel vehicle consists of a plate placed on a chassis. Jetson Nano depth camera is located on the plate. At the bottom, there is a battery, servo motor and driver motor. Large wheel diameters are designed for ease of driving. The vehicle is planned weight between 4-7 kilograms according to preliminary design plans. It's 460 mm long, 325 mm wide and 240 mm high. This is how our vehicle looks from different angles.
Hello, I am Muhammed Keçeci. I will present the third part of the presentation. There are 5 stakeholders in our project. These are passengers, rental car companies, rental shared vehicle companies, the Ministry of Transportation, and the General Directorate of Highways. These stakeholders have some expectations from the project, and these expectations are called stakeholders' needs. On this page, there are these needs. We determined some technical requirements according to these stakeholder needs and listed these technical requirements as follows. We have selected some components to meet these technical requirements, listed hardware and software as follows. This is what the system block diagram of the project looks like at level 0. Shared autonomous vehicle gets the initial location and destination from the user and environmental data from the environment. It finds its location with environmental data. It calculates and sends arrival time and travel fee to the user. If the user requests this travel, the vehicle starts going to the initial location from its location and it sends its instant location until it arrives user's location. Its environment changes with motion. When any important thing happens, like an accident, the vehicle sends a notification about what happened and how late it will be. When the vehicle arrives, it sends a security password to the user, and the user must enter this password to the end user interface to get in the vehicle. And this is the system block diagram of the project at level 1. The sensors detect the environment and produce raw data. This raw data needs processing to become useful. This processing is done in data sensor fusion using various algorithms. The data processed and useful layer is transmitted to the SLAM subsystem and obstacle and object detection subsystem. With this data, the vehicle can understand its position and state in the SLAM subsystem and the obstacles in its paths, traffic lights and traffic signs in the obstacle and object detection subsystem. But these are not enough to explain the route and motion of the vehicle. The vehicle also needs to know the locations to which it will go, and it gets this data from the user via mobile application user interface. This interface sends the data to the SLAM subsystem via a server. With all this data, the motion and route of the vehicle are present in the motion and path planning subsystem. This subsystem outputs velocity commands. These commands are processed in the kinematic and dynamic control of the vehicle subsystem to determine which engine will rotate at which speed, and the necessary output is given to electronics. The engines are driven by a specially designed motor driver and the vehicle moves. As the vehicle moves, its environment changes and the cycle continues until the vehicle reaches its destination. On this page, there is the flowchart of the process I just described. This is the working schedule we have planned. The dark blue areas show the works we have done, the light blue areas show the works we plan to do. This page is the last page of our presentation. These are our deliverables. Thank you for listening to us.